today we're going to talk about right triangles. And what we're going to do is we will solve for all angles and all sides in a given triangle based on some given information. In my first triangle, I'm given that theta is equal to 35.6 and C is equal to 14.5. What I don't know is side A, side B, and let's call this top angle alpha. Let's start by finding alpha. I know all triangles have 180 degrees, and I know I have a right triangle on the corner. So alpha along with theta will add up to 90 degrees. To get the value of alpha, I'll take 90 minus 35.6, which will give me 54.4 degrees. Now I'm ready to solve for sides A and B. Let's start with A. If I'm looking at A is adjacent to theta. Adjacent makes me think of cosine. So cosine of theta, which is 35.6, will be the adjacent A over the hypotenuse C, and C is 14.5. To solve for A, I'm going to multiply both sides by 14.5. That'll cancel on the right, and on the left I can grab my calculator and enter 14.5 times cosine of 35.6, and it gives me that A is equal to 11.78996,104. For the first time, I'll again talk about what do we do with all of these decimal places. Well, we look at the chart. And the chart says, looking at our original theta, which was 35.6, it had one decimal place. I give 3 significant digits in my answer, so 3 significant digits says I should make A 11.8. I still need to solve for B, so similar to what I did with A, I look at B in relation to theta. Well, B is opposite. Opposite makes me think sine, so I say the sine of 35.6 is the opposite B over the hypotenuse 14.5. And just like I did in the last problem, I'm going to multiply both sides by 14.5. And enter 14.5 times the sine of 35.6 in my calculator. B will give me 8.44. Once again, I'm using 3 significant digits to my 1 decimal place from my angle. So I'm going to do this a lot more times. I'm going to give us different angles, different information so that we can solve. So in this one, A is my angle and it's equal to 53.1 degrees. C is my hypotenuse and it's equal to 346. Okay. Hopefully you're thinking just like the last one. It's easy to get B. This angle B would be 90 minus 53.1. This is 36.9 degrees. This is B. So let's write that up there. Now let's go about finding side A and side B. Let's start with side A. A is opposite of angle A. Opposite says let's try sine of 53.1. That's going to give me the opposite side A over the hypotenuse 346. Hopefully you remember last time we just multiplied both sides. So I'm multiplying both sides by 346. Grabbing my calculator and saying 346 times the sine of 53.1 gives me that A is equal to 276.69. Right. Let's stop there. And again, remember, I had 1 decimal place in my measurement of my angle, so it says I can give 3 significant digits in my answer. 3 significant digits is looking at the 276. 0.69 tells me round that up and make A 277. Let's do the same thing with B. With B, I'm adjacent. So adjacent looks like cosine of 53.1. And that would be the adjacent B over the hypotenuse 346. Just like last time, I start by multiplying both sides by the denominator of 346. 346 times the cosine of 53.1 says B is 207.745398. All right. Again, I'm making sure we understand what to do with the decimals. We had the 1 decimal place in our angle, says I need 3 significant digits in my answer. The 207 is what I'm looking at. The 0.7 tells me to round up, and B will be 208. Let's look at another one where I'm giving different information. This time B is this top angle, 23.8, and I didn't give you the hypotenuse, I gave you the height, which is 7.25. As always, I think what's the easiest thing to do? And the easiest thing to do would be to solve for the angle A. Angle A is going to be 90 minus 23.8. Which is 66.2 degrees. So this time, because I was given angle B, I'm going to do all of my solutions based off of angle B. What I don't have this time is the hypotenuse, and that's what I had in the previous two. So I need to rethink about how I'm going to go about this. So sine and cosine both require the hypotenuse, but tangent does not. So maybe a nice place to start this time would be to look at the tangent. Here I have B, so if I look at the tangent of the 23.8, it would be the opposite, which is A, over the adjacent, which is 7.25. Now I multiply 7.25 times both sides. 7.25 times the tangent of 23.8 gives me 3.197631001. Okay, we stop a minute and we say, one more time, I had 1 decimal place in my degree, so I'm going to give 3 significant digits. A is going to be equal to 3.20. I had 3.1976. That rounded up, right? The 7 pushed the 9 up, which made it a 3.20. I have a value for A. I still need to find a value for C. So to get the value for C, again, remember, I'm trying to use So to find the value for C, I'm looking at B was equal to 23.8, and I know that side B is 7.25, and I think, well, what kind of relationship could I use with the side B and C? Well, what I want to use is cosine. If I look, the little b is adjacent to the angle B. So this says the cosine of 23.8 is equal to the adjacent 7.25 over the hypotenuse C. So you've done this a few times now, and you should be used to the idea that we end up multiplying both sides by the denominator in the ratio. This time that denominator is C. So now the C is no longer in a fraction. I have C times the cosine of 23.8 is 7.25. But notice I don't yet have an answer. I'm going to have to divide by the cosine of 23.8, cosine of 23.8. So let's try that in our calculators. 7.25 divided by the cosine of 23.8. This is 7.92. Let's double check. 1 decimal place in our degree, 3 significant digits in our answer, and that's what I've given you. I don't want you to think too hard about what rule do I use, how do I know what to do when. I think set up the problem based on the things you know, based on you know sine, you know cosine, you know tangent. And then the work will come out of there. You'll try to solve for whatever variable is missing, and sometimes you may have to multiply and divide, sometimes you may just have to multiply, but don't overthink it, don't try to come up with new rules about what to do, just go with each problem and see what it leads you to. All right, here's another one. Now this time's a lot different because I haven't given you any of the angles in this one. I've given you two of the sides. I've given you 4.25 and I've given you 12.5. We know one side is 90. We don't have to worry about that one. But let's say I would like to know A. Okay. If I want to know A, I look at, well, the 4.25 is adjacent and the 12.5 is the hypotenuse. So I could say that the cosine of A is the adjacent 4.25 over the hypotenuse 12.5. Once I have that, remember how I solved for A? I used the inverse. So I will say cosine inverse of 4.25 over 12.5 is equal to A. So in my calculator, I'm hitting cosine inverse 4.25 divided by 12.5, and it says A is 70.123, right? It keeps going. I'm going to stop there and look back and see, what do I think I'm supposed to do? I can say I have three significant digits for both of my sides that were given. So 3 significant digits says you can give the degree to one decimal place. So I should make this 70.1 degrees. Okay. Now I know angle A. Let's do angle B. Angle B is easier. I can do 90 minus 70.1, which is 19.9 degrees. Okay. So I know angle A, I know angle B, I know two of the sides. I have one side remaining, which is side C. You have a bunch of choices in this part, which is kind of nice. So you could use the trig functions and say, look, I know what A is. You could also use the Pythagorean Theorem. Why don't we try both, see what we get. So one way, which would be using the trig functions, I could look at C as the opposite of A, which says the sine of 70.1 would be the opposite C over the hypotenuse of 12.5. At this point, we should be used to the fact that we are going to multiply both sides by 12.5. And we put 12.5 times the sine of 70.1, which says our side C is equal to 11.7536. Again, we like to pay attention to what are we allowed to do. You can see 3 significant figures in the other two values, so we're allowed to have 3 here, which is 11.8. But what if you didn't want to do that? What if instead you wanted to do the Pythagorean Theorem? Pythagorean Theorem would say 4.25 squared plus c squared is 12.5 squared. Let's make this easy. Let's put over 12.5 squared minus 4.25 squared. We can put that in our calculator. So 12.5 squared minus 4.25 squared. This gives me 138.1875, but then I want to take the square root of that, and I get, again, C is 11.7553, whatever, keeps going, but remember we're looking for 3 decimal places, or 3 significant figures, which means it's 11.8. I like showing you there's 2 ways to do it. That way you can pick the one that works best for you. There's not a, this is the way you should do it. There's a, whatever way works for you is what I want you to do. Right. So once again, I'm given 2 sides. I have 23.9 and 15.7, and I need to figure out everything about the triangle. I like to go with the angles first if I can. So I say, look, I can try to figure out what angle A is. Once I know A, I'll know B. Here I'm given the opposite and the adjacent. So when I go to solve for A, think about opposite, adjacent. What kind of trig function should I use? Hopefully you're thinking I should use tangent. This says the tangent of A would be the opposite, 23.9, over the adjacent, 15.7. Then use the tan inverse function of 23.9 over 15.7. That's going to give me A. When I go to get A, I'm going to have 3 significant digits from my ratios, so that says when I go backwards, I should have one decimal place when I tell you what the degree is. So I'm putting in tan inverse of 23.9 divided by 15.7, which says A is 56.7 degrees. Okay. Once I know A, B is pretty easy. I do 90 minus 56.7, which is 33.3 degrees. Okay, A is done, B is done. Now I need to go, well, I'm missing a side. We're going to call that side C. It's the hypotenuse. Let's do the same thing I did last time, which is let's do it two ways. So way number one says, why don't I incorporate what I found out, which I found out this angle here was 56.7 degrees. And I could use that to solve for C, and then I'll also use the Pythagorean Theorem. But let's start with using trig. So with the trig, I could say, well, the sine of 56.7 degrees is equal to the opposite, 23.9. So now to get the value of C, I have two choices. I can use trig, I can use Pythagorean Theorem. Let's start with trig. The trig part would say, let's use the sine of 56.7. It would be the opposite, 23.9, over the hypotenuse C. I'm going to start by multiplying both sides by C. So now I have C sine of 56.7 is 23.9. And we're going to have to divide by the sine of 56.7. Okay. 3.9 divided by the sine of 56.7 gives me that C is equal to 28.6. Just so we've done a comparison, let's also use the Pythagorean Theorem. Pythagorean Theorem would say 23.9 squared plus 15.7 squared is equal to C squared. 23.9 squared plus 15.7 squared, I have 817.7 is C squared. Okay. Square root says that C is equal to 28.6, right? Once again, we got the same thing, and I'm glad to let you have your choice of how to solve it. Looking at this triangle, I can see A is equal to 33.75. B then would be 90 minus 33.75, which is 56.25. But that's where I would stop. There's no way for me to figure out the lengths of any of the sides because I don't have a value to start with. So if I come across a problem like this on the homework, I would say not enough information to solve.